At 0818 hours local time on the 29th of November 2023, a violent explosion occurred deep inside Russian territory, shaking the entire Severomuysky area. The flames from the explosion could be seen from the opposite side of the mountain about 13 miles away, while a column of thick black smoke rose more than 270 feet into the air. A Russian freight train consisting of 41 cars carrying fuel, weapons, and artillery ammunition was engulfed in flames. But what made this attack different from everything previously witnessed was the distance. The train was located deep inside Russian territory, thousands of kilometers from the Ukrainian border. This route was protected by multiple layers of security and dense, modern defensive systems that the Kremlin had once declared impenetrable. Yet, 8 Ukrainian UAV pilots proved that nowhere inside Russian territory could be considered completely safe. And they did it using drones that cost even less than a standard smartphone, 30 miles away. Members of the Security Service of Ukraine, the SBU, were monitoring degraded video signals through control-link transmitters operating at extreme range. 8 FPV drones were crossing distances and terrain that Russian military experts believed made the mission impossible. A standard FPV usually has an operational range of only about 5 miles, but these UAVs had flown more than 12 miles and were still continuing forward. Behind the formation, Ukraine's main Directorate of Intelligence, the SHUR, continuously provided real-time intelligence. At the same time, Ukrainian electronic warfare units monitored and intercepted Russian communications. A team carrying anti-jamming equipment also remained on standby, prepared to penetrate the electromagnetic interference layer if the situation required it. Then suddenly, the images on the control screen began stuttering violently, covered with bands of interference and repeatedly cutting out. Only a few seconds later, the signal disappeared completely. The link between the attack UAVs and the control crew had been severed. The first relay UAV, the critical link maintaining communications for the mission at a distance of 35 kilometers, had just been destroyed. A Russian 9K-38 Igla-S manpads had locked onto and struck the UAV while it was hovering at an altitude of 1,400 feet. Without the station, the control signal could not pass through the terrain and the jamming zone ahead. The transmitted images flickered, navigation commands arrived late, and then could no longer reach the attack UAVs at all. Without it, the entire formation would now lose contact with its operators. And within only a few more seconds, the entire mission could collapse. This is the greatest challenge of every extreme-range UAV operation. Maintaining precise control when the signal must cross nearly 30 miles of mountains, dense forests, and electronic jamming zones. Ukraine uses a control link system operating across the 2.4 to 5.8 GHz frequency range to create an almost instantaneous connection. Digital signals can travel farther, but a delay of about 200 milliseconds is too dangerous. When a UAV is racing toward a train moving through a tunnel entrance, that delay can cause the impact point to miss by as much as 20 feet. In this ambush, 20 feet could determine whether the FPV strikes the designated position or misses entirely. But the control link has one weakness. In dense forests and mountainous terrain, a stable signal can usually travel only about 3 miles. Therefore, the SBU had to deploy a chain of 10 relay UAVs, each spaced 3 miles apart, creating a communication corridor extending from the control station to the Severomuysky tunnel. The primary UAVs flew at high altitude to optimize transmission. The backup UAVs flew lower, concealed by the terrain and background clutter to avoid Russian radar and surface-to-air missiles. They were also positioned far apart so that a single interception could not destroy multiple links at the same time. But the primary relay UAV had just been shot down. Inside the control station, the SBU members watched screens filled with static for 3 seconds, 5 seconds. They waited for the signal to switch automatically to a backup route, but the image continued appearing and disappearing. At the 6th second, the backup relay UAV was activated. It was flying at an altitude of about 500 feet, making it more difficult for Russian air defenses to detect. But it was positioned as much as 1.5 miles away from the optimal transmission point. The signal strength recovered to only 50%. The video was still torn into fragments, and the altitude data jumped erratically. The image sometimes disappeared for several seconds, but that was enough. The SBU pilots regained control of the 8 FPV UAVs that continued racing toward the Russian train. This was not an easy mission carried out by a single unit. The attack required multiple Ukrainian units to coordinate for several weeks. The SBU controlled the 8 UAVs and maintained the 30-mile relay chain. Near the entrance of the Severomuysky tunnel, a partisan group supported by the HUR had secretly placed an explosive charge containing 180 pounds of explosives beside the railway track beyond the tunnel entrance. The explosive charge had to detonate at the exact moment the locomotive emerged from the tunnel, while most of the 41-car train remained trapped inside. Too early, and the train could stop before reaching the ambush point. Too late, and the most important cars carrying fuel, weapons, and artillery ammunition would pass beyond the lethal area. Meanwhile, the Alpha unit monitored Russian communications for signs that the ambush had been exposed. Ukrainian electronic warfare teams monitored the sources of interference, ready to intervene if the UAV signals continued to weaken. Each unit held only one part of the operation, but all of them had to act at exactly the right moment. The SBU pilots had spent hundreds of hours training under conditions of distorted video or completely black screens. When they lost the image, they used railway tracks, rivers, and power lines as navigation references. Count to 15. Bank slightly to the right to follow the railway track. Count another 10 seconds. Descend when approaching the heavily forested mountainside. The maneuvers, repeated hundreds of times, were now the only thing preventing the UAVs from crashing into the forest or the mountainside. Ahead, the 41-car Russian train was still advancing toward the Severomuysky tunnel. 8 FPV UAVs were approaching from multiple directions. The lead UAV was still 18 miles from the target. The next few minutes would determine whether 180 pounds of explosives would turn the entrance of the Severomuysky tunnel into a massive trap or whether Ukraine's weeks-long operation would end without leaving a trace. But when the lead FPV was still 15 meters, miles from the target, the image on the control screen suddenly broke into blocks. The video flickered, control commands responded slowly, and the UAV icon began drifting away from the flight corridor. The delay increased from 50 milliseconds to more than 300 milliseconds. The FPV had just entered the operational zone of the Borsoglepsk-2, a mobile electronic warfare network that Russia had deployed in advance. A reconnaissance station detected the control link signal and transmitted the data to the command post. Within only a few seconds, multiple jamming stations simultaneously joined the attack. One station targeted the video signal on the 5.8 GHz band. Another suppressed the 2.4 GHz control channel, while a third source distorted the positioning data on the SBU screens. Everything nearly collapsed at the same time. The image disappeared, the direction became inaccurate, and every command arrived late. The control crew immediately reduced the amount of transmitted data. Instead of attempting to maintain high-quality video, the system sent back only isolated frames along with minimum parameters, such as altitude, speed, and flight direction. The video transmission rate dropped from about 30 frames per second to only 1 frame every 2 or 3 seconds. The FPV continued advancing using inertia, its pre-programmed route, and terrain reference points stored in its memory. From that moment on, the pilots could no longer control it entirely by sight. They had to estimate the UAV's position between signal windows that lasted only a few seconds. The Borisoglepsk-2 was extremely powerful, but it could not concentrate maximum power on every channel at the same time. Each time one station switched to a new frequency, an extremely brief opening appeared in another part of the network. Ukraine did not need to break through the entire wall of interference. They only needed openings long enough to check the UAV's altitude, direction, and relative position. One frame appeared, then disappeared. 2 seconds of clear data came through before the screen once again sank into interference. Within the formation of 8, 4 lead FPVs flew widely spaced in front. The leading UAV served as a probe, forcing the Borisoglepsk-2 to continuously change its antenna direction and suppression mode. Each time it found a temporary signal corridor, the data was immediately passed to the crews behind it. 30 seconds later, the second FPV entered that exact corridor before the Russians could completely reconfigure the jamming system. The next two changed their altitude from 500 feet to 300 feet and altered their approach direction to avoid being identified as a single cluster of electronic targets. The remaining 4 UAVs continued approaching along different axes, but the Boris Glebs 2 had not yet used its most dangerous measure. The system began spoofing navigation signals on the Ukrainian map. The UAV icon suddenly shifted several kilometers away from its actual flight path. If the pilots trusted those coordinates, the FPV would leave the railway line and fly directly into the mountainside, but they no longer depended entirely on satellite signals. The control crew compared flight time, speed, wind direction, and the terrain features appearing in the brief video frames. A road appeared for less than 1 second, then a strip of forest, and finally, the corner of an industrial area appeared at the edge of the screen. 3 reference points confirmed that the FPV was still inside the correct corridor. The coordinates on the map were false, but the UAV had not been pulled away from its flight path. As the formation entered the densest part of the jamming zone, the Ukrainian electronic warfare team activated its final option. A high-powered directional transmission penetrated the suppression layer and opened a brief electronic window. The image from the lead UAV reappeared, blurred, shaking violently, almost completely without color, but clear enough to recognize that the railway tracks were still leading toward the Severomuysky tunnel. In return, the Ukrainian transmitter immediately lit up on Russian electronic reconnaissance equipment like a lighthouse in the darkness. The operator placed his hand on the switch and counted every second. 10 seconds. 20 seconds. The Boris Glebs 2 stations began rotating their antennas and narrowing the search area. At the 25th second, Ukraine cut the transmission. The equipment was packed away, and the vehicles immediately left the position before Russia could complete the coordinate fix. The UAVs switched back to autonomous mode. GPS continued jumping erratically, and the video still flickered, but the lead UAV had correctly re-established the approach corridor. The 3 lead UAVs followed its data. The remaining 4 advanced from different directions, using the railway tracks and terrain as navigation references. After flying nearly 8 miles through the Boris Glebs 2 suppression zone, one final image returned to the SBU screen. It was still blurred and constantly flickering, but in the center of the frame, the railway tracks were leading directly toward the Severomuysky tunnel. All 8 FPVs were still in the air. Through the dense interference, the SBU pilots finally saw the 2 railway tracks leading into the tunnel blurred beneath them. The 8 FPVs immediately descended to an altitude of 170 feet and followed the railway line. The GPS was still jumping erratically, but that no longer mattered. As long as the cameras could still see the 2 steel rails, no false coordinates could pull them away from the approach corridor. The control crew switched completely to manual mode, navigating through low-quality frames that appeared and then disappeared after a few seconds. The Russians immediately activated the Pole 21. Distributed jamming stations along the railway corridor simultaneously increased their power, suppressing GPS, GLONASS, Galileo, and Beidou signals throughout the entire area. The positioning data disappeared completely, but the 8 FPVs did not turn back. They continued following the railway tracks through their cameras. The Pole 21 had disabled satellite navigation, but at the same time, it forced the UAVs to switch to a method it could not jam, what the cameras could actually see, when the formation was only 6 miles from the train. The Panzer S-1 radar detected the lead FPV. The target was locked. The fire control computer determined its speed, altitude, and interception point. The launcher began turning toward the railway line. Only 8 seconds remained before the first missile left the launch tube. But Ukraine had prepared for this exact moment. Suddenly, 6 new targets appeared on the Russian radar. They were $500 decoy UAVs fitted with corner reflectors that made them appear much larger and more dangerous than their actual size. Within seconds, a single target became an entire formation racing toward the train. The Panzer's computer could not distinguish between the cheap decoys and the warhead-carrying attack FPVs. The Russian crew was forced to choose: fire at every target and risk running out of missiles, or delay to classify them and accept the possibility that the real UAVs would break through. They decided to fire. The missiles left the launchers one after another, racing toward the largest signals on the radar. But the decoy system did not work perfectly. The cold weather weakened the batteries and affected the handmade electronic circuits. Nevertheless, the Panzer launched 8 of its 12 missiles at devices built from racing drone components, cheap materials, and even energy drink cans. Within only a few seconds, 2/3 of the system's missile stock had been expended on false targets with a total value lower than that of a laptop computer. The Pol-21 had caused the UAVs to lose GPS, and the Panzer had detected the formation and opened fire. But the 4 lead FPVs remained intact and continued following the railway tracks. The other 4 were closing in from behind and from different directions. Russia's modern defensive layers had not stopped the attack. They had only helped Ukraine identify the Panzer's position and forced the system to expend nearly all of its missiles. Before the real targets appeared ahead, the 41-car train was preparing to enter the Severomuysky tunnel, and the 8 FPVs were now only a few minutes of flight from the 180 lb explosive charge. The Panzer S-1 now had only 4 missiles remaining, but the system had not yet lost its defensive capability. Beneath the launchers were 2 twin 30mm 2A38M automatic cannons with a combined rate of fire of nearly 5,000 rounds per minute. At a distance of less than 2 miles, they could turn the entire railway line into a wall of fire. The 8 FPVs immediately descended to an altitude of about 30 feet, almost skimming the tops of the grass. But the Panzer did not need to lock precisely onto each target. The Russian crew turned the turret toward the railway tracks and began pouring fire across the entire approach corridor. 30mm rounds tore through the air, and columns of dust continuously erupted directly in front of the formation. If they continued flying straight, all 8 could be wiped out. The 2 lead FPVs immediately broke away from the formation. One climbed away from the railway tracks and flew directly toward the Panzer radar. The other circled toward the right flank and approached from behind the turret. The Russian crew was forced to shift its fire. The first was destroyed less than 1,000 feet from the Panzer, but the second continued diving toward it. For several critical seconds, all of the firepower was drawn away from the main flight path. The remaining 6 FPVs descended lower and passed through the blocked area. 2 UAVs had been sacrificed, but the approach corridor had been opened. At 07:56 hours local time, the locomotive of the 41-car train began entering the Severomuysky tunnel. The 6 FPVs were now only about 4 kilometers from the ambush area, but the SBU still did not give the order to attack. The UAVs slowed down and held their positions behind the mountainside. They had to wait for the locomotive to appear at the tunnel exit on the other side, while most of the fuel, weapons, and artillery ammunition cars were still inside. At nearly 0817 hours local time, the Alpha unit intercepted a brief message from the Russian railway security forces. The locomotive was about to leave the tunnel. The SBU pilots immediately pushed their control sticks forward. The 6 FPVs accelerated simultaneously, followed the railway tracks, and raced toward the explosive charge containing 180 pounds of explosives. The Panzer still had 4 missiles, and the Pol-21 was still jamming, but the defensive corridor had been torn wide open. And in less than 1 minute, the Russian train would appear at the exact position where Ukraine had been waiting for several weeks. Through the heavily distorted video signal, the SBU pilots could see only a trail of black smoke rising above the forest. The train was accelerating toward the Severomuysky tunnel, but a 41-car train could not immediately reach its maximum speed. It needed time it no longer had. The remaining FPVs were only about 2 miles from the target, racing along the mountainside at nearly 80 miles per hour. In less than 90 seconds, either the UAVs would be destroyed or the train would be engulfed in flames. As the locomotive began entering the tunnel, Russia's final defensive layer was activated. An R-330 GGTEL electronic warfare system installed on the train increased its transmission power, creating an electronic suppression zone around the railway line. The system was designed to jam GPS, GLONASS, and satellite links within a range of 20 kilometers. The positioning data disappeared almost immediately, and the electronic compass began giving incorrect readings. But the weak control link signal continued transmitting through the chain of relay UAVs. The image had been reduced to flickering black and white fragments, but the pilots could still see the mountainside and the two steel rails below. From that point, they switched entirely to manual control. The UAVs followed the railway tracks, circled around the mountainside, and raced toward the tunnel exit on the other side, where the explosive charge containing 180 pounds of explosives was waiting. The original plan was simple. One FPV would strike the detonating device just as the locomotive emerged from the tunnel, causing the explosive charge to detonate while most of the train was still trapped inside. But when the locomotive appeared at the tunnel exit on the opposite side, the jetel suddenly increased its power to the maximum level. The control link signal nearly collapsed. The video froze, and control commands arrived late. The explosive charge was only a small target positioned beside the railway tracks. With the image appearing and disappearing, the chance of hitting it had fallen to almost zero. The SBU was forced to change the plan. Instead of striking the detonating device, the lead FPV would attack the first fuel car. The secondary explosion from tens of thousands of liters of fuel could trigger the explosive charge positioned near the tunnel entrance. Through one brief frame, the operator saw the locomotive racing out of the darkness. Behind it were the first freight cars, with the train traveling at nearly 40 miles per hour. At that speed, the targeted fuel car would remain inside the impact corridor for only about 6 seconds. The operator began counting. At a distance of less than 500 feet, the image disappeared completely. The FPV was now flying almost blind, relying only on its approach direction, calculated timing, and reflexes developed through hundreds of hours of training. 3 seconds, 2 seconds, 1, at 0817 hours local time. The first FPV crashed directly into the lead fuel car. A burst of fire erupted beside the tunnel entrance, but that was only the first explosion. The anti-tank warhead on the FPV exploded the instant it struck the side of the fuel car. The red-hot metal jet pierced through the steel plating and punched into a compartment containing 40,000 liters of diesel fuel. In less than a second, the fuel turned into mist and ignited. A fireball erupted right at the tunnel entrance. The temperature at the center of the blaze quickly exceeded 1,800 Fahrenheit. The flames curled nearly 200 feet high, engulfing the locomotive and the cars behind it. The emergency braking system activated immediately. The steel wheels locked, ground against the rails, and dragged the 41-car train to an abrupt stop, exactly where Ukraine had been waiting. The locomotive and the first cars had already cleared the tunnel, while nearly half of the train was still trapped inside the mountain. 10 seconds later, the second FPV plunged into the smoke at nearly 80 miles per hour. The camera could barely see anything. The screen flashed white from the heat, then went black as the control link signal continued to be suppressed by the R330G. The pilot was no longer looking for train cars. He was looking for the rails. The two steel tracks appeared for less than a second, but that was enough to confirm the approach direction. The operator kept the control stick centered and calculated the distance by speed. The FPV tore through the flames and slammed into the fuel car directly behind the first impact point. The secondary explosion ripped steel plates away from the railcar frame, spilling burning fuel onto the railway bed where it spread straight toward the 180 lb explosive charge hidden near the tunnel entrance at 0818 hours local time. The fire reached the detonating device. A burst of white light engulfed the tunnel entrance. The shockwave slammed into the mountainside, was compressed inside the narrow space, and then surged deep into the tunnel at an initial speed of more than 2,000 feet per second. Rock, concrete, and reinforcing bars were torn from the ceiling. Part of the tunnel mouth collapsed onto the railway, burying the cars near the exit under hundreds of tons of earth and stone. The pressure also surged back inside. Fuel cars and artillery ammunition cars trapped in the tunnel were shaken violently. One fuel car deformed and its piping and safety valves burst apart, releasing flammable vapor into the enclosed space. A few seconds later, half of the train inside the mountain exploded. The new shockwave was trapped between the rock walls, rebound back and forth through the tunnel, destroyed the ventilation system, and blasted metal fragments outward like artillery shells. Outside, the column of fire rose more than 270 feet high. Through the control screens, the SBU pilots could see only a wall of black smoke. The final 3 FPVs were still in the air. The tunnel entrance had collapsed, and the fuel cars at the front were burning. But some artillery ammunition cars, near the head of the train, were still intact. The first FPV circled around the mountainside, dropped below 40 feet, and struck directly at the coupling between the locomotive and the ammunition car, tearing apart the coupling and brake lines to prevent separation. The next FPV came in from the opposite direction and slammed directly into the middle of the car, triggering internal ammunition detonations. The final FPV struck the wheel assembly beneath the ammunition car, derailing it and throwing it into the burning fuel. The locomotive was destroyed, the railway was buried, and the cars inside the mountain continued burning in the enclosed space. All 8 FPVs were gone, but the 41-car train had no escape route left, as the black column of smoke rose above the Severomuysky range. Russian forces began to realize that the explosion had locked shut one of the most important supply routes across eastern Siberia. The Severomuysky tunnel is part of a vital railway corridor connecting Western Russia with the Far East, China, and North Korea. Weapons, ammunition, military components, and goods must pass through transport routes like this before being moved toward the Ukrainian battlefield. A single explosion forced trains behind it to stop, change routes, or wait for repairs. Every hour of disruption meant fuel and artillery ammunition could not reach storage depots or frontline units. The operation was carried out nearly 6,000 kilometers from Ukraine, deep inside Siberia, a region Moscow once believed was beyond enemy reach. To carry it out required an intelligence network operating inside Russian territory, special forces capable of reaching the railway line, and UAV pilots skilled enough to control 8 FPVs across nearly 30 miles of mountainous terrain through multiple layers of air defense and electronic warfare. Defensive systems worth millions of dollars could not prevent low-cost UAVs from reaching the train at the precisely calculated moment. The attack exposed a major vulnerability in Russia's security system. Even one of the country's deepest strategic transport routes could no longer be considered completely safe.